So, in this video we are going to discuss a problem of physics in which a point charge is present and a line charge is present. They are separated by a certain distance and we have to calculate the electrostatic force acting between them. So the problem is such that we have a Q charge which is a point charge, and from this charge at a certain distance, say A, there is a line charge present. Line charge present up to a length L. We can call this line charge as a rod which is having a linear charge distribution over it, and the linear charge distribution over this rod is such that every point of this rod is having a constant charge. If you take 1 unit of length of this rod, you will get same charge. If you take second unit of this rod, you will get same charge, and so on. We get same charge around each and every corner of this rod. So to define the charge present in this rod, we have an entity, physical quantity called linear charge density. What is linear charge density? Linear charge density is charge present on this rod per unit length. So if the total charge Q is present on this rod, we define linear charge density as charge per unit length, Q by L. So using this, we can find out the force acting between this Q charge and this line charge. This Q charge is taken as positive charge. So the force is actually repulsive in nature. To get the correct mathematical equation of this force which is acting between these two entities, physical entities, we have to take x and y axis. Why we have to take x and y axis? To get the correct and accurate mathematical expression through which we can arrive at a correct answer. Now, suppose this is our y axis and this is our x axis. We can take this point charge Q at any point on this x and y axis. To get the correct or easy mathematical equation between these two between these two entities, we take point charge on the origin, and after taking point charge on the origin, we take a certain distance A, and after that distance your line charge will start. This line charge will start like this. Now what we have to do? Firstly, we have to see the direction of the force which is acting between these two physical entities. Now, this charge is positive and all the charges present here are positive. So, the forces is repulsive in nature, and if we take this portion of the rod, it will have a repulsive force. This portion of the rod will also have a repulsive force. Accordingly, all the portions of the rod will have repulsive force. The net force will come on this rod in this direction, so that our direction gets fixed. Our direction of the force in this rod gets fixed. So why we have to fix the direction of the force? Because when we are going to do the integration, it will not create any complication due to the different directions of the forces. So we have analyzed here that there is a similar direction of force present here, so we can do easily integration here. Okay. Now to do the integration, we have to take a certain portion of this rod, say dx length portion we have to take, and in this dx length portion we have to find the charge present. So suppose in this dx portion we have dq charge present on this rod. What is the value of dq? We have to find out firstly. So we have charge per unit length, that is linear charge. So it tells us that unit length has charge lambda. Unit length has charge lambda. Okay, this is the definition of linear charge density. So if unit length has charge lambda, what should be the charge present on dx length? Lambda into dx. This is the value of our dq. Now we know from Coulomb's law, if two charges are present and they are separated by a distance r, the force of repulsion or attraction, which is called Coulomb force, present between these charges are F is equal to A to the power of Q by R square. Similarly, we have this point charge here, and the dx length we can consider this portion as point charge also. So we have one Q point charge, and at a distance x, we have dq point charge which is present in dx length. We can apply Coulomb's law here, which tells us that if suppose the force between them is df, suppose the force between them is df, so F becomes df, q1 becomes q, q1 becomes q, q2 becomes dq, and the distance between them is x square. Now we will integrate it. While integrating, we have to take lower limits and higher limit. So the lower limit of this rod gives the value of x as x equal to a, and the higher limit of this rod, that is a plus l. This length of the rod is l. So this is the higher limit of x, that is this x equal to a plus l. In between these lengths, in between this length, x can vary because we have chosen x in between it. So the lower limit of x as x equal to a, higher limit is x equal to a plus l. Now we have to integrate it. df integration will be f and kq, we can take it outside. Firstly we have to put the value of dq. dq value will be lambda dx. Lambda dx by x square. And a plus l, we have to do the integration. We can take out kq lambda outside and we can do the integration of 1 by x square. Integration of x to the power minus 2 is minus x to the power minus 1. So we can write a plus l as kq lambda minus x to the power minus 1. This is our integration value, and the limit is a to a plus l. Now f we got as kq lambda, and 1 by x, lower limit is a, upper limit is a plus l. Minus is also present here. Okay, so we can take minus outside. Minus kq lambda we will get, and 1 by x a plus l. First we put upper limit, then we put lower limit. Minus kq lambda 1 by a plus l minus 1 by a. So on solving this, what we will get? A minus l. So the final result will be minus kq lambda minus l. We get on the numerator, on the denominator we get this. So the final result will be, we can write this as f minus minus will get cancelled out, kq lambda l by a plus l. So this is the force which is acting between this rod and this point charge. Okay. So this is how you do in your examination. You can use this direct result on the examination also. So that's it from this video. We'll meet you in the next video.